let's look at an example of pressure and forces. So suppose we have this concrete column which has a density of 2400 kilos per cubic meter. And let's suppose the cross-sectional area of this column is 1 meter squared. And the height of this column is 3 meters. And what we want to find is the pressure exerted by the column on the ground. So if we take a free body of this column, well, what we have is a force of weight pulling that column towards the ground. And we're going to have an equal and opposite force pushing that column out of the ground, which is the normal force. So a vertical sum of forces, the sum of forces in the vertical direction is 0. So what we have is the normal force is equal to the force of weight. And what do we know about the force of weight? Well, that's the mass of the column by the gravitational acceleration. And we know that mass is equal to the density by the volume of the column. Okay, so as we're given that the density is 2400 kilos per cubic meter. And the volume of the column, well, we're given the area and we're given the height. So area by height is going to give me 3 meters cubed. And the gravitational acceleration is 9.8 meters per second squared, which will approximate as 10 meters per second squared. So what we get is the normal force is equal to 2400 by 3 by 10, which is effectively 72,000 newtons. Okay, because we can see that meters cubed is going to cancel, so we get kilometers per second squared, which is newtons. And that's the same thing as 72 kilonewtons. Okay, so we're asked to determine the pressure on the ground. So pressure is equal to the magnitude of the perpendicular force. So in this case, the force is perpendicular to the ground. That will be 72 kilonewtons. And we divide by the cross-sectional area. So as we can see, the cross-sectional area here of the column is 1 meter squared. Okay, so what we get is 72 kilonewtons per square meter, which is the same thing as 72 kilopascals. Well, if we draw the pressure distribution in 2 dimensions, well, what it's going to look like is something like this. But in reality, it's going to act on this entire base of the column. And I'll see you in the next video.